All right, here's our last thing we're going to talk about for this unit, graphing, which should be a review, but let's get into some details about it so you guys know what's going on. So in graphing, you have two things. You have two variables. You have independent and dependent variable. Okay, changing one variable, which is going to be the independent, that's what you control, so it'd be anything you can control, will often change the dependent variable. So measuring a reaction as the rate temperature is increased by applying heat. Temperature is what you controlled. You heated it up, and the rate of reaction depends upon the temperature. All right, here's another example. Measuring the volume of a gas trapped in the cylinder as pressure applied. Pressure is the independent variable because the volume is dependent. So the volume depends upon the pressure. So more pressure, little volume, so on and so forth. Here's what graphs should have, all right, in order to make it work. They should have an x and y axis with the independent on the x, okay? Independent variable on the x, kind of important. Don't forget the units too. Dependent variable is on the y, don't forget the units. A numeric scale, okay, so in other words, the range on the x and the y. So in other words, from like 0 to 10, 0 to 20, stuff like that. Make sure they have a title, dependent versus independent. All right, so in other words, y versus the x. All right, so dependent versus independent. For example, above would be a reaction rate versus temperature. All right, and remember the independent is always on the x, dependent is always on the y. Data points, circle with protectors. In other words, the data points that you actually took, dot them and circle them. All right, that's good so you know that where they're going to go. And then you got to give me a line of best fit. Okay, so a line either connecting those dots, whoops, a line either connecting those dots or a line that curves between the points. Your call how you want to do it. So then once you have that line, you can interpolate. In other words, determine what happens between the data points. And if you extend it beyond your data points, you can extrapolate. In other words, going outside your range. All right, so an example of interpolation, I took these two data points right here. I can determine this because between my data points. Between. Inter means between. Extra means going beyond. This measurement right here is beyond your normal set of data points. So therefore, you're just called extrapolation. All right. Once you can do that, interpolate and extrapolate, you can do those things. But this, if you want to know what should be in a graph, kind of a big deal right here. Make sure you guys know that this stuff should be in your graph when you're making graphs. All right. So when you have a graph, there's different relationships that go on. There's direct and indirect relationships, and they're kind of normal represented graphs. So for example, direct relationships is basically as one goes up, the other goes up, or as one goes down, the other one goes down. So an example would be this one, so as one goes up, the other one goes up. Or you could say as one goes down, the other one goes down. So it's either going to look like this, or it could really look like the opposite way too. Indirect or inverse relationship as one increases, the other one decreases. So they're going to do the opposite. So as the x increases, the y decreases. So they're going to do the opposite. This one, they do the same thing. This one, they do the opposite or inverse relationship. All right. So make sure you know the difference between direct and indirect. One goes up, one goes up, one goes down, one goes up, one goes up. They both do the same things. So try your hand at the practice problem with graphing. See how you guys do. There's graph paper and what's going on, and we'll see if you guys can figure out the interpolation, extrapolation. Use your notes. They will be very, very helpful. So the graph paper you need is going to be over by the goggle cabinet. And then we'll go through these as an example. All right, so now we're where you stop. Do this, and then you can try one. All right, so here's your information. Here's your data. So identify what's things going on. Well, it says the students determined the temperature of the soil was measured at the start of the experiment before the light was turned on. Then the measurement turned on. So what did you control? You controlled the temperature. Well, you didn't. Sorry, you controlled the time you did it. So your independent variable is how long you took your data. So that'd be the time. As the time increased, what changed? The dependent, which would be the soil temp. Okay, this one made this happen. So once you create a graph, you should see, I'm just going to do a really rough graph here. So here's my graph, let's say. And let's see, independent variable goes on the x, so we're going to go 0, 1, 2, 3, 4, 5. This is really rough, so don't hold me to it. And this, let's see, we start at 20, 25, 30. So 0 minutes, we are at 19. So we started right here. 1 minute, we went to 23. Right about there. Second minute, we went to 24. Right about there. Third minute, we're at 25. Right about there. Roughly. Remember, this isn't an exact graph. Fourth minute, we went to 28. So we're getting up to here. And fifth minute, we went to 30. So now we have this. There's my line. Pretty much straight up and down. Okay? So there's my line of best fit. I can interpolate and extrapolate. Stuff like that. So, predict the soil temperature at 6 minutes. Well, I could say let's say at 6 minutes, it's going to be roughly. So this is 6 minutes is going to be somewhere up here. Well, let's say it's going to be right there. I would say it's going to be roughly about 35, just off my best guess. 35. Did I enter or extra? I went beyond, so I went extrapolation. How do you know? Beyond data set. It's beyond my data set. Okay, next one. So like this, pitch soil temp at 3.5. So between the third and the fourth. So I would say it's probably going to be right around 26, 27. So I'll say 27. It's interpolation because it's between data. Okay, it's between the data points I already took. What type of relationship? Well, as one increases, the other one also increases. So this would be a direct. Why? Because as time increases, what also increases? Soil temp also increases. That's why it's direct. All right, so hopefully that helped. It's kind of quick, but it should be a review. Talk to you guys later.